20 minutos.
Perdón, la presentación también es hacia usted, ¿verdad? La presentación también es hacia usted, ¿verdad? O me dirijo totalmente al video. 3. Good morning, we introduce you to our project. In this case, we're going to present a transfer and receptor circuit. We are talking about RF by radio frequency data transmission. Okay, and for that, in first place, we're going to present ourselves. The components to our team are Anconeira, Checa, Yamel, Cuadros, Sandhaus, Jeancarlo, Huaman, Chambi, Alvarez, Piero. We belong to the A and B team from the career of electronic and automation industrial automation. All right. Then we go to start with the project. Okay. The introduction. In this part, we can talk about the project that we pretend to create. In this part, I talk about what are we using for this project. As you can see, we are talking about the AS key, the modulation, because that is the modulation we are using for our project. As you can see, the RF is way to transmission, and this especially have four kinds of bands of range, four kinds of range of RFID. That means microondas range. We have four. In first place, we have the low frequency that use between 120 and 140 kilohertz that belong to low frequency. Then we have high frequency that is over the 13.56 megahertz. Then there is the ultra high frequency that is between 860 and 960 megahertz. Then we have the microwaves or microondas that it's over the 2.45 gigahertz and over. Okay. Then we have in this case we are using the module or RF, especially most commonly known as 433 megahertz. We can see the emitter module here and the receptor module here, over here. We adapted these coils to function as antenna. Okay, we have some characteristics of these modules. The transmitter, we can see some characteristics, and the receptor another other. As I say before, we are using a key modulation or know it to OO key. That is the same but most simple modulation. It's like binary but in the most simple form. Same here. And then we start with the presentation of our Gantt diagram. That is how we take the times, how we deliver the times to create this project.
Here we can see that Gantt diagram where we can see how deliver the time in the weeks. Then first how we define the basis of project, and then playing the dates of the project and how it put in the diagram by the components for the project, for design the circuit. 5. Simulation of the circuit. 6. Design of the board of PVC. 7. Construction of circuit. 8. Test of function working. And never close the project. Then materials. First, the HT12E, one component. Switches, battery of 9 volts, sockets, model of radio frequency, resistors of Unca and Variety, and finally nets and integrated capacitors LM7805 triacs and board.
In the design of plates of circuits, first we designed the plates in Igor program. Here is the max of received triad. First, here the max of receipt of triad. Then the implementation of plates. Finally, the implementation, the components in the PCB. Here we have the components over the plates, soldering. Right.
Now we see the function of the project. First, in the project we have the receptor of RFI. We have encoder. We have the decoder. We have a gate. It's a NOT gate. First, in the first part, we have a simple logic binary control. For example, zeros or ones, and we have the power control. We can control voltage in AC and to 220 volts. And in the transmission, we have the encoder. The encoder is an encoder binary, sends the information to the receptor. He decoded the information and transformed to binary. And the first we have place to see all the signals that the transmitter sends us to that. We start the function. We supply the energy of the transmitter. If you see, there is a red LED that indicates that the receptor have brought the signal of the transmitter. Now we have the two circuits in the function. For example, if we press the first button, we can see the first lead is illuminated, and the second, the third, and the fourth one. There is parameters of this antenna. The characteristics of this antenna is if you get the higher distance, we have to use an antenna of 17 centimeters to reach, for example, until 30 meters to control this. We can take advantage of this power control. For example, we have MOX and we have 3x to control the AC the power control. Pause. Yeah, in this case, we have to control the power control with a motor in DC. If you see the motors turn around. Yeah, now we make a test with the control of the power control. If we press the first button, we can see the motor turn back to the clockwise. This is the control of our brake. It's a result.
Thank you.